Good morning children and welcome to online teaching session. Today I am going to continue the same topic, that is electronic displacement in covalent bond. In this topic earlier we discussed some topics. Today's subtopic under this main topic is inductive effect. Inductive effect. Now let us see the concept, what is meant by inductive effect and what type of compounds we are going to see this type of effect. Those organic compounds which contain hydrocarbon part in it and electron withdrawing group like halogen, nitro group, CN group, cyanide group, carboxylic acid group. These are called electron withdrawing groups. So when one of this type of electron withdrawing group is connected to carbon atom of an hydrocarbon chain, say alkyl group, then delocalization of electrons or movement of electrons will take place towards which element of that organic compound it takes place. Because of that, what type of charges are developed over carbon atoms and the electron withdrawing group. This is what we are going to see in this phenomenon, that is inductive effect. To understand this, we will take an example of CH3, CH2, Br. This is nothing but bromoethane. Bromoethane. In this case, we have two parts. This is hydrocarbon part, that too alkyl group, and its specific name is ethyl because it has two carbon atoms. Eth means two carbon atoms. Ethyl, and the other one is halogen, that is bromine atom connected to ethyl group. So this is acting as bromide. Now in this molecule, this is one molecule of an organic compound. This electron pair, single bond means electron pair, double bond means two pairs of electrons, triple covalent bond means three pairs of electrons or 6 electrons. In this case, now what happens is this bond pair of electron or electron pair will move towards Br. As a result, what happens is Br will get more electron density over it, and this carbon atom, first carbon atom to which Br is linked, will get positive charge. But here one point to be kept in the mind, that is Br will not be fragmented from ethyl group. Means Br will not be separated from ethyl group, will not be separated. That is why Br will not get completely negative charge. It will get little negative charge, right? And this carbon atom will not get completely positive charge because of movement of this electron pair towards Br. This carbon will get little positive charge. Second carbon atom will also get little positive charge. But how are these little negative, little positive charges shown? Let us see. CH3, CH2, Br. Since electron pair move towards Br, so Br will get little negative charge. To represent or to indicate little, we use this sign. This means little. This is delta. So Br will get little negative charge because that bond moved close to Br. Since that electron density moved away from this carbon, so this carbon will get little positive charge in this way. Delta positive. That's how we need to read. Delta means little. Next, second carbon atom will also get little positive charge, but that is indicated by this sign. So in this case, delta minus, this should be read as delta minus. It means little negative charge. So delta means little. Next, delta plus. Means little positive charge. So here this sign should be read as delta, which means little. Triangle sign is also read as delta, but that is used in those reactions where heat energy is required. Whenever we are going to give heat energy for the reactant, if it is decomposition reaction or to the reaction mixer containing more than one reactant to react chemically with each other, so there when energy is required, above arrow mark we write delta sign, that is triangle sign. So that is also delta, which stands for heat. This sign should be read as delta, which means little. Delta minus means little negative charge, right? Delta positive, delta plus means little positive charge. And children, you should remember that delta positive is less than delta positive in quantum of positive charge. Quantum means degree, that means quantity or amount. When two deltas are there with two different positive signs, means one has only one unit of positive charge, other one has two times plus plus, delta plus plus. This means the quantity of positive charge is less when compared to the other sign which has only one plus sign. So here, movement of this negative charge means bond pair will take place towards that Br or towards that atom which has more electronegativity. Here Br is more electronegative, that's why it is pulling that electron pair or bond pair of electrons towards its side. So it has moved close to Br or away from first carbon atom. Next, if we take bromopropane, that also exhibits inductive effect. If we take bromobutane, which contains more than 3 carbon atoms, means 4 carbon atoms are there in bromobutane. So when number of carbon atoms becomes more than 3, that inductive effect vanishes. So this is other point to be noted. So inductive effect vanishes when number of carbon atoms is more than 3. Next point. Because of inductive effect, atom gets negative charge and group of atoms will get positive charge. This is called polarization or appearance of polarity. So next point is polarization takes place. At the beginning of starting this inductive effect, I told about electron withdrawing group. Here, electron donating groups can also be there in this phenomenon. So, we have electron withdrawing group, electron releasing or donating group. That is in the molecule of the organic compound. So, we have two types of groups. Right? They are number one, electron donating group. And second type is electron withdrawing group. Now, what are called electron donating group? Those groups which are able to give electrons, release electrons, donate electrons are known as electron withdrawing groups. Now let us see example for that is methyl, ethyl, etc. groups. Right. Electron withdrawing groups means electrons to be taken. They should not be given. Right? Electrons should be taken from those groups which are able to give the electrons. And best example for electron withdrawing groups are OH minus, Cl minus, COOH group. Otherwise, we can write like this. Instead of this minus sign, single bond OH, single bond Cl, single bond COOH. This is hydroxyl group, cyanide group, carboxylic acid group. Methyl group means CH3 group. Ethyl group, C2H5 group, etc. So in this way, we can write as many electron withdrawing groups as possible. So that's about inductive effect. So inductive effect is nothing but the one of the phenomena wherein electron displacement takes place. This is best example for that phenomenon. This is an organic molecule, right? In this case, we have halogen, that is Br, which is able to withdraw electrons. So here, if you want to then add X dash X, single bond X. X stands for halogen. Right? It can be chlorine, bromine, iodine. So here Br, why it pulls electrons towards its side is it is more electronegative. So head of the arrow mark shows that electron is pulled towards its side. So here in this case, instead of this curved arrow, we can show like this also. And here also. Right? We can show curved arrow, or we can show in this way also. Head of this arrow mark shows moment of covalent bond, means electron pair towards that atom which is attracting that electron pair. So that is about inductive effect, and these are the changes which are going to take place during inductive effect phenomenon. Yes, children. Now we will move to cleavage of bonds. That is known as fission. Fission in organic molecules. This is different topic. Fission in organic molecules. Fission means breaking, one meaning, right? Division, cleavage. These are the different terms which can be used in this phenomenon. First, let us see what is meant by fission, particularly in the case of organic compounds. So, all organic compounds possess covalent bonds in them, and these covalent bonds are formed when electron pair is shared or when electron pairs are shared, right? And this organic compound usually contains carbon, hydrogen with oxygen, halogen, phosphorus, sulfur, and so on. Right? And when can fission of the bond take place? If you take organic compound, example, we can go for ethyl bromide, common name, bromoethane, IUPAC name. If you take bromoethane, in the case of bromoethane, same example was taken in inductive effect, right? So in the case of bromoethane, Br is more electronegative. So what happens is the bond which is binding carbon atom and Br in bromoethane will be shifted completely towards Br in this fission phenomenon. Right? That is one thing. Next, during fission what happens is electron pair, instead of shifting completely towards one of the atoms, what happens is that electron pair is cleaved in such a way that each fragmented part, separated part or cleaved part will attain one electron with it. Right? Then that type of cleavage means this is second type. In earlier case, bond is completely shifted towards one of the fragmented part. In second case, bond means one pair of electron will be divided equally and each fragmented part will retain one electron with each. That is second type of fission. That means we are going to get new particles based on that type of fission. So fission means breaking of bonds. Breaking of bonds. Breaking of bonds in organic molecules. So, in the case of breaking, we can use the term cleavage also. And based on the formation of the new particles because of fission, we have two types of fission. What are those two types? Number one. Yes, children. Now, let us see the second type, that is homolysis or homolytic fission. Here you need to remember the meanings. If you remember the meaning, you can recall the concept easily. That is, lysis means cleavage or breaking. Hetero means different. Hetero means different. Homo means similar. Now, come to the concept. First concept is heterolysis or heterolytic fission. In heterolytic fission, hetero means different, right? Lytic or lysis means division. An organic molecule, when it is subjected to cleavage at suitable temperature or in presence of light energy, that molecule will be divided in such a way that two different fragments will get. That is what hetero means. Hetero means different fragments, different products. Different particles we can say. Different particles we will get. What are those particles? Let us see. To understand this, we can go for bromoethane molecules. So here concept is breaking off the molecule in such a way to give two different fragments is known as heterolytic fission. Each fragment or each particle will have particular amount of particular charge. Let us see one example for this. CH3, CH2, Br, bromoethane, you can take, or CH3, Br, you can take. Now, in the case of this molecule, when either heat energy or light energy, the energy is required. It can be heat or light. In presence of light or heat energy, what happens is this bond means electron pair. So it can be shown like this also. CH3, single covalent bond means electron pair. Right? So single covalent bond that will be moving towards Br completely. Means that bond is broken. Cleaved. As a result, that single covalent bond or electron pair will be moving towards Br or away from the carbon atom of alkyl group. This alkyl group is here methyl. As a result, what happens is we will get CH3 positive ion and Br minus negative ion. Head of the arrow mark shows movement of that electron pair towards one particle whose electron negativity is greater than the other, that is Br. Now this is known as methyl cation or methyl carbocation. Carbocation refers to carbon atom of that particle which has positive charge. Right? And this is bromide anion. Right? So we have got two particles with two different charges. That is what hetero means. Right? Now the molecule is cleaved. It has undergone heterolysis. Lysis means breaking. Because of that, we have got two particles of opposite charges. Now, let us see the important points. Here, Br contains 8 electrons in it. Outermost shell. In its outermost shell. If you take carbon atom of methyl group, that contains 6 electrons. Right? So, we can write carbon atom of CH3 attains sextet. Doublet means 2 electrons, triplet means 3 electrons, sextet means 6 electrons. Sextet of electrons in its outermost shell and Br minus attains 8 electrons in its valence shell. 8 electrons means octet. Eight electrons in its valence shell. This is important point. Next, so formed ions are associated with particular amount of charges. So they are reactive and unstable. Those which are reactive, right? They may be inorganic species, need not be always organic species, are always unstable. Next, if you take methyl cation, has sp2 hybridization with triangular planar structure, right? Now let us see stability order. Before going to start stability order, you should know types of carbon atoms in carbocations. In carbocations, we have three types of carbocations. There are 1-naught carbocation, right? 2-naught carbocation. In that way we have 3-naught carbocation. Now let us see what is meant by 1-naught carbocation. Best example for this is CH3, CH2, and our carbon atom of CH2 have positive charge. Means carbon atom which has positive charge should have connected to other carbon atom. There should not be any branch. Next, 2-naught carbocation means 2 CH3 groups should have been connected to one carbon atom, wherein that carbon atom should have positive charge. Isopropyl group, wherein carbon atom has positive charge. Right? So 2 alkyl groups are connected to single carbon atom. So it is 2-naught carbon atom, carbocation. Next, 3-naught carbocation means, in this case, 3 methyl groups are connected to one carbon atom which has positive charge. In this way. So this is 3-naught carbocation. 1-naught carbocation means primary carbon primary carbocation. 2-not carbocation means secondary carbocation. 3-not carbocation means tertiary. Ter means 3. Tertiary carbocation. Now come to stability of these carbocations. If you take CH3 wherein carbon has positive charge, it is less stable than the other group which has 2 carbon atoms in it, that is ethyl cation. And this ethyl cation is less stable than isopropyl. CH3 twice CH cation means secondary cation, and this is less stable than tertiary carbocation. This is the order. This order, these groups may be given in jumbled way, and you may be asked to put them in correct way. 4 options will be there. Out of those 4, 1 option will be correct. Means in the form of MCQ this can be asked. The most stable carbocation is tertiary carbocation. The least stable carbocation is primary. These 2 are primary carbocations. Right? These are examples for primary carbocations. So that's about heterolytic fission concept, right? What type of particles with what type of charges we are going to get, and types of carbocations, and stability order of the different carbocations. Thank you, children.